Well, hello and welcome to Into the Terminal. Today, Nate and I are going to be covering disk encryption. So, Nate, to start us off, we're going to talk about doing some Lux-based disk encryption, correct?
All right, so let's get my share going. And we're just going to take a basic RHEL box. This is a RHEL 9.1 system. I built it fresh for this demo. We're going to just take it. I have a disk attached to it that I'm going to show you right here. This VDB1 down here. This is just an empty disk, a little 1 GB disk, a virtual disk I attached to the VM. We're going to encrypt it, and we're going to show you basically how that works and some of the ins and outs of how that works. So first of all, now that we know what the disk is, we're just going to use there's a tool called Crypt Setup, which you have to install. I've already got it installed in this machine, but we're going to throw the command in here. So Crypt Setup -y-v Lux format. This tells it to format the disk as a Lux volume, and of course, what you want to format. It asks you have to specifically write the word yes in all capital letters because it does not want you to accidentally Lux format a different disk. So yes, yes, I mean it. Very affirmative there, all capitals. And then it's going to ask us for a password. Now, it's very picky about its password policy. I didn't dig into how you can modify the password policy. I just made a password that works, but is easy enough for me to remember for this demo. Give me just a sec here.
And when else will we use this password, Nate?
Every time you unlock this disk, you're going to need this password. Now, there's ways to automate that. We're going to talk about that a little later, but this is essentially what encrypts the disk. This password is, in the cryptographic algorithm that says this is how we unlock this disk. So I'm going to I pasted it there. We're going to paste it again.
And what happens if you forget this password, Nate?
Oh, if you forget the password, basically you lose your data. I tried looking. There does not seem to be a backdoor recovery method here. This is it. You lose this password, you lose the data. So do not lose this password.
That is correct. And we actually use this technology at Red Hat on our work issued laptops.
Yep.
And I can confirm that if you forget your password, no one will be able to decrypt this data again. So essentially, you're going to throw away whatever is on that disk and start over. So remember
Right.
to keep your password. Don't forget it. If you need to put it somewhere where you can remember it or recover it, you need to do that as an additional step for your setup.
Right. Right. So and that's a feature, not a bug.
Well, we could talk about a little bit more in
Yeah.
the
Yeah.
deeper dive.
So let me just clean up the screen here a little bit, and then we're going to now. Okay, we've got the volume formatted. What can we do with the volume? Right? Oh crap! Copy paste fail. Got all that extra crap at the beginning. There we go. All right, so crypt setup, again, this is the same tool we used, and what we're telling it is to open the volume, Lux open. The volume, of course, the disk here is devvdb1, and we're giving it a name. I'm just giving it the very creative name of my vol. Anyone who's ever been through Red Hat training will recognize that as like the default for anytime you're setting up a virtual volume, and that's exactly what this is, right? It creates a virtual volume that maps to the encrypted volume, however it's unlocked, right? So we do that, and it's going to ask us for that password. Now, if I didn't have this, we'd have a problem. But luckily, I do have it. Super secure. You're going to see it later, I promise. You'll see how super secure it is. But for the moment, you're not going to see it. So there we go. Now it's created, or now it's unlocked, and we should have a virtual volume. So Scott, do you know where virtual volumes show up on a RHEL box?
Are you talking about dev mapper?
Right. So if we do ls block again, this will show us all the disks on the system, including virtuals. So now you see we've got underneath VDB, there's this virtual crypt volume, right? And if we look in dev mapper, my vol. Right. Now, what do we do with the volume? We mount it, right? That's of course all we really need to do. Now I made a mount point here in mount. I think it's here. Nope, I got to make it. Sorry, I should have done this before the demo. If you don't restore con, it will sometimes give you SE Linux fits. So I had to do that quick. All right, so now we can just mount this. Mount dev mapper myvol, mount myvol. Uh-oh, what did I do wrong?
You forgot to format it with a file system, so it's
I
now
did.
an
You're
encrypted
right.
volume, but it doesn't have any file system on it.
The volume exists. I missed a step. I missed a very important step. Let me clear the
But we
screen
would
again.
have to have it active before we do that.
Yes.
Though, right?
So you have to. I only missed the make a file system step. So basically, once you've created the encrypted volume, and you then open the volume, now you've basically got an empty disk. And you're right, Scott. So we're just going to make an XFS volume on dev mapper myvol, and ta-da! Now we should be able to mount it just fine. Okay, now DF should show us mount myvol. There it is down there. I know it's a little obscured. Let me clear the screen again. Let's put a file there just because we need something to show that the volume opens later, right? Super secret. I don't know why I keep doing dev instead of mount. Right there. So now we've got a file. So just that quick, right? And the only piece I skipped here was like making a partition on the disk. I had prepared that already, and installing the crypt setup tool, which is just, I think it's just called crypt setup. I didn't put it in the notes, but maybe we'll include that in the show notes later. There is also an article that we're going to include in the show notes from Enable SysAdmin about going through setting up encrypted volume if you want to step through and see all the details. But there we go. Scott, you have a question?
Yeah, so that's if you want to manually attach this thing whenever you need to use it. But what about getting it automatically attached when the system?
Right. So obviously, so what'll happen here, that crypt setup, the crypt setup command we use to open it will not run automatically. If you want to do that, what we now have to do is add it to, there's a separate file similar to like fstab, or you've heard the word tab for like cron tabs and, you know, init tab and all that stuff for things that are stored and to run automatically, right? What we need to do is get the UUID of not the virtual volume, but the physical volume, VDB1, okay? So to do that, we use a tool called block ID, BLK ID. And I have to hit enter in the right screen here. All right, now we need this UUID, but not this whole string, right? So obviously this gives us information about thing. What we need here is specifically this UUID equals and then the UUID, okay? So we're going to copy that. Now we're going to edit etc. Now this file does not exist. See, if I hit tab, it doesn't exist yet. This is something you have to create. CRYPTTAB. There's 2 T's. That messed me up the first time around. Now I'm going to paste the UUID in here, but only because I want to get that off my clipboard. Basically do myvol. So what this is telling crypt setup is there's a volume. I want to call it myvol. You could change that here if you wanted to. It doesn't have to be the one you used the first time around. You could call it Bob. I don't care. And then the UUID, and that is the UUID is the identifier for dev VDB1. So this essentially tells it a block device with this ID should be mapped using crypt setup with the name myvol. And what that'll do is next time you boot, it will read this file and it will automatically try to unlock that. Okay.
So just a point of clarity here. The myvol tells us what device we're creating under the dev mapper.
Right.
So as long as you have the name set here, and it also matches where.
So the myvol name doesn't have to match anything you've already got created. This you're essentially saying at boot time, make a device called myvol and map it to this UUID, which is devvdb1.
Oh, I think I may be getting a little bit ahead, Nate. So the myvol, the device that you're creating here for DevMapper, you can
Right,
change it to whatever you would like it to say,
right.
whatever identifier you want to have. But when you list it in your FS tab to get mounted at boot
Yes.
time,
Yep, we're doing
whatever
that
the
next.
DevMapper string is has to match what's in the Etsy FS tab.
Right. So now, a thing to be aware of, even if you don't put it in Etsy FS tab yet, adding it to crypt tab will make it unlock at boot. Okay. And there's a way, well, we'll talk about that in a little bit. Let me first add it to FS tab because I do want it to not just unlock it, but mount it at boot. So we're going to make a new line. We're just going to, I've got the format already here. We're going to paste it in. So the device we're mounting is devmapper myvol, because that's what it'll unlock and map to once it's created. We're going to mount it to mount myvol. It's an XFS partition, as Scott pointed out that I forgot to do before. And we're going to mount it with the defaults, right? So we're going to save that. Now what will happen is at boot time, crypt setup will unlock the volume, and then we should be able to mount it, or it'll mount automatically like any other file system. Now, there's a caveat there, but we're going to talk about that after the break. Right, Scott?
Sounds great. All right. Well, welcome back after the transition. Where we left off was we just created our Lux encrypted file, Lux encrypted volume with a file system, and Nate, you had set it up to automatically open at boot time and get mounted at your mount point.
Right.
But wrinkle.
Right. Now, so do you guys remember what we had to do when we opened the volume last time? Someone in chat. Maybe, oh, there's a delay. This isn't going to work that well, is there? What we had to do when we opened the volume was enter that password. Remember we said without that password, you can't read the data. When you reboot, it doesn't know the password anymore because when you shut down the system, or even if the system ungracefully shuts down, it relocks the volume, right? So I've got a quick demo here of exactly what that's going to look like. So here I've got the VM console for the machine that we just set up that volume on. And we're just going to reboot it, right? So I'm going to click the reboot button here. Now, what should happen is it'll reboot like normal. I know this may be harder to read. It's difficult to change the font size in this, so you're going to have to bear with me.
Your system.
So I show this to bring.
World, Nate.
Sorry, it's going to take a moment. Sometimes this is my little old hypervisor that it's a decade old. I bought it on eBay. It's like an old HP ProLiant down in my basement. So you're just going to have to give it some time. All right. So what you couldn't see now, it looks like it's hung, right? It's not actually hung. It's waiting for input from me, but unfortunately the console output made it scroll off, but it asks me for the password for that Lux volume that we told it to unlock at boot time. So let me highlight the window here. We're going to type in the password, and you should see stars come up as I'm typing. And we hit enter, and it should finish boot. Oh, there we go. Not in the file system, XFS, and we should get a login prompt any second here. Now, obviously, like, that isn't ideal that I had to type that. Why isn't that ideal, Scott?
Well, if we're talking about like a data center, I would have to connect to the machine's console in order to enter the password whenever the machine was rebooted. So if I'm relying on like automatic recovery of services and other things in the event of a kernel panic or something else, that wouldn't happen because it would be stuck waiting for that prompt.
Right. So that's not great. Now, I mentioned earlier about that crypt tab. There is a way you can basically have crypt set up. You can have it generate a key, and then you can point crypt tab to that key. And then at boot time, it'll use the key to unlock instead of having to ask you for the password. Now, that's great from I don't have to physically log in, physically sit down and type in a password on my my console every time I reboot my server at say 2 in the morning when you're doing updates, or the power just flashed and your UPS didn't hold the system up and it rebooted all by itself, and now all your services are down because no one's there to type the password, right?
And we actually
However,
use that in a really weird and dumb way, where we'd put the key on a USB drive and like plug that into the back of the machine, and so
right,
every machine had a unique USB drive that went with it that contained the key to unencrypt its LUKS volumes. But
right.
before we start getting into automating this, maybe we
Hmm.
should take a minute to just talk about some of the data encryption, like how it's stored, things like that.
Sure. So as we went through with the setup, right? It's formatted in a LUKS format. I wanted to grab the type of keys and whatnot that it used, and I forgot to throw them into the show notes. I don't know if you have those on hand, Scott.
I don't, but I was thinking more about how it's encrypted at rest.
Oh, that's what you meant. Yes, perfect. All right. So obviously, an encrypted disk is only as good as the whether it's locked or unlocked, right? Your data is not protected essentially when the disk is unlocked. What it's protected from is if someone were to physically take the disk, or I don't know, take the virtual disk if it's a VM in the case of my system here, or think about the use case of, say, your laptop, like Scott was talking about, his corporate laptop locked using LUKS. If you take your laptop to Starbucks and you forget it there, or someone steals it, or you leave it at the airport, right, while you're traveling, whatever, right? Now, if someone gets a hold of that thing, they can't get your data out, just like Scott couldn't because apparently he forgot his password at some point.
To be fair, well, I have forgotten my key for a variety of other encryption algorithms and technologies. I have never forgotten my one for LUKS because it was made so apparent
Yeah.
when we started with LUKS that if you forgot it, kiss your data goodbye. Like you cannot recover it. It is gone
Well,
because it's encrypted at rest and you can't unlock it again.
the thing with a standard LUKS encrypted volume is if you've got your whole laptop encrypted with it, it's very difficult to forget that password if you're using it every day. Because I don't know how you deal with your work machine, but I generally turn mine off at night because I want to disconnect, right? Because we're all work from home, and that's important to not work after hours. I know from your work habits, maybe that's not true, but I would shut my machine down every night, and when I turn it back on in the morning, I'd have to type that LUKS password. It gets pretty quickly ingrained in your long-term memory.
Yeah, I actually don't shut down every night. But like I don't use password managers or things like that so that I am forced to repeat it over and over again to commit that to memory.
Right.
But I think that the other thing to think about in this part of our security arc, right, where we talk about compliance and security policies and things like that, there are a few security policies that require a technology like this. A good example is HIPAA, which is used to manage medical data for providers in the United States. So they're talking about the same kind of thing that Nate was just talking about, right? Like a disk is decommissioned out of a server, or um, an array, a storage array, is decommissioned out of the hospital or whatever.
Mm-hmm.
And you send that thing to the recycler, you send it to wherever it's going after it's been decommissioned. You don't want that data to be accidentally accessed by someone else. And
Accidentally. I like
so,
how you phrase that, Scott.
right, you don't want to leak information by accident to you.
Right.
So HIPAA requires encrypted volumes, and this is the method that we would use for uh, putting that into place. That way, as you decommission the machine or you decommission the disks off the machine, they're encrypted at rest, and the person who receives that equipment afterwards doesn't have the encryption key to open it, which means to them it's just encrypted goop, right? They can't
Right.
actually get the medical records back out of it again.
Right. Now, you could argue, and you and I have had this conversation, so I realize that I'm rehashing stuff we've talked about already, but you could shred your disks, whether using the Linux command line shred or some other utility. I used to use a boot utility that I would boot off of, and it would shred disks before they were sent to the recycler. However, those are not foolproof. Some of them are better than others, right? And especially in the days of NVMe disks and whatnot, from what I remember, a lot of older shredding utilities don't shred a solid state disk as well as they used to shred a physical disk. You don't have, not physical disk, platter disk, right? Spinning rust, I've heard them called. But so that's why these compliance policies say you have to have it encrypted, because then if you just rip it out of the server and put it on the recycle pile, you didn't have to take any other action. It couldn't be accidentally forgotten. Oops, I didn't shred that one before it left, right? So just another layer of security there. So,
and one last point before we talk about the next thing.
Mm-hmm.
So we talked about how this was encryption at rest, but now that we've got it open and mounted, processes, people on the machine, they have access to the data as long as the file permissions and the XFS file system permit them access to it, right? So your applications are still able to access it while the volume is unlocked and mounted. It's only when your system is unmounted or that volume is locked, when it's been put to, I don't know, inactivity, I guess, that the data is being protected by this Lux encryption format.
Right. So there was discussion. I remember this like way back when disk encryption. I shouldn't say when disk encryption was starting, but when it was becoming more commonplace and when it was starting to get required by these different governing bodies, that encrypting the disk somehow made your data more secure. Well, when it's unlocked, exactly as Scott's saying, it's not more secure. So it's still more important. It's still important to remember, encrypting your data in flight, encrypting your data when it leaves the machine, over TCP connections or whatever, even encrypting the data that's locally being communicated between services on the machine, right? Because if someone can somehow listen in on the TCP stack on your server, right? A lot of people just say, oh, it's not leaving the server, I don't need to encrypt that. And in a lot of cases, you're right. It's really hard to get that data out, but it can be sniffed, it can be gathered, and it can be viewed, right? So the more encryption you deploy, obviously there's sometimes a CPU cost to that. So there's a bit of a trade-off there. But with modern CPUs, it's negligible, right?
And we have like a whole technology stack around that, right? Like secure socket layer and TLS.
Right.
And so, yeah.
The bar to entry is a lot lower than it used to be.
I have been paying attention to chat, so if anybody has questions while we're talking, please feel free to put them there. But Nate, we also want to talk about resolving our last issue, which is like we have to be physically present to type in the password when the machine reboots.
Right. So we talked about how you can use CryptTab to automatically unlock with a key. That's fine, but it's not fine. And the reason I say it's not fine is because that's a file on your machine, right? And a determined attacker could collect that before stealing your data, right? Now, again, we're like put on the tinfoil hat. We're getting more and more levels of paranoia here. However, there is a solution that will allow you to unlock those disks via a network service that does not exchange private data. It doesn't exchange the actual password. It doesn't exchange the key that will unlock the volume. It uses a key exchange similar to Diffie-Hellman. And I wanted to jot down the name of it, and I forgot to. It's in one of the docs that we link in the notes for today's show that I had made sure I put in our notes here. But it's very similar to Diffie-Hellman's public key exchange, where there's a server that knows about your disk and can unlock it as long as your server can reach that server. And the technology I'm talking about is called network-bound disk encryption. The server we're talking about is called Tang. And then there's a client that runs on your machine called Clevis. There, Eric was nice enough to throw it on the screen here. McCollum Relia. Maybe I butchered that. And what I've got here is a quick demo of setting up network-bound disk encryption using our system role, right? So if you guys are familiar with RHEL system roles, if you watch RHEL Presents, you'll know there's a certain co-host there that seems to work web console and system roles into every episode he possibly can. So what I've done here is I've already got this set up. This machine is my hypervisor. I happen to use it as my Ansible control node. I don't do a ton of Ansible, but I've been doing more of it lately because it's so convenient, right? If you guys, maybe we'll do another episode on Ansible someday. What do you think, Scott? But maybe not. So in here, I've got a couple files. I put a link to a blog written by Brian Smith himself about how this works. It's what I followed to set this up. I guess we'll start with the inventory here. So I have an inventory. It basically says there's systems that are NBDE servers. That's the Tang server I was talking about. And NBDE clients, which is where Clevis will get installed. Now, I just got two machines here. I named one Tang 0, and the other is the machine we just set up Lux on. Okay, so I'm setting this up using the encrypted volume that's already in place on C server 0, which is the one I was doing the demo on before. That's one of the prerequisites, right? Network-bound disk encryption won't go set up your encrypted volume. It already has to exist, right? Now we're going to look at the actual playbook. Actually, no, let's look at, these are the group variables for the playbook, which basically tell it what disk are we decrypting? That's devvdb1. What's my super secure password? Lux pw123. Yes, that passed the, the validation. Red Hat with a bunch of substitutions did not, however. So maybe there's something in there that says anything that resembles Red Hat cannot be used. And of course, then we define what server it's supposed to connect to. In my case, this is on my local network in my lab. So I'm just using an IP address. You can use a DNS name there as well. Same thing with the hosts, right? If you've got these things named in a way that your machine can resolve, you can use the host names in there instead of the IP addresses. But I don't have DNS set up in my local lab because I'm a slacker. All right, and then the last thing is the playbook itself. Sorry, this is probably not the best way for a stream. Let me do it this way. We'll use good old Vim because we get color coding and stuff. All right, we have to open up a firewall port. It does use port 80, not encrypted. You will notice that. The reason it's not encrypted is because it doesn't need to be. Remember I said the data it's exchanging is not private, right? Now, could it be encrypted? I don't know, maybe. Should it be encrypted? Maybe you can add that as another layer of security. I didn't dig too deeply into that, so we're going with this. Like I said, the key that it exchanged, by the way, there's another interesting piece about those keys. Tang can rotate them. So if you wanted to have a key rotation policy where every 90 days you change keys, you can do that without having to change the Lux password, right? Because it doesn't have the Lux password. It's not sending the Lux password. It's sending this key or this key exchange. You can rotate those so that you can, if your keys were sniffed and you're worried about that, you can rotate them every so often. All right, then we're going to deploy the Tang servers themselves. This is, again, the RHEL system role for the NBDE underscore server. There's another one called NBDE underscore client that goes to the clients. This, I feel bad about this. I didn't dig into this. Brian's article mentions that you need to do this. You're basically adding a piece to the boot environment for the kernel and adding it to Dracut. He said it was to work around an issue. I don't know if that issue's been resolved. I meant to go back and look at it, but I didn't get a chance to. And then, of course, we deploy the clients, right? And again, this is RHEL system roles, NBDE underscore client. All right, now that all sounds very complicated, but the RHEL system role makes it really simple. All we have to do is take this one I copied down here. Let me go get it out of my notes. So from the directory where I've specified all this stuff, right? So this is basically what we've got here. Let me clear the screen so you can get better output. All we do is run Ansible playbook. We use the playbook that we defined the inventory that we defined there, and we hit enter. Now, as long as I've got everything set up right, and I think I do, this should just kind of go through and set stuff up. So let's give it a second here to play through.
So that's it opening up port 80 on the firewall.
Yep. Now it's doing. See, it even mentions key rotation there. Making sure it has keys. And this, believe it or not,
I like how
sorry,
it's
go ahead.
telling us which system it's working on. So like your server is .42 and your client is 39.
Yep. Okay. Just about done here. I feel like this is always fun when we're staring at a terminal, waiting for it to do things, and we don't have much to say at the moment.
Well,
Anything good in chat that I'm missing?
We call it network-bound disk encryption, but there's 2 open source projects that make it work.
Mm-hmm.
Clevis and Tang. And which one is which for the server and client? As I hit you right as you take a drink.
Yep. So Tang, and these are pieces of a lock, believe it or not. I wanted to look up which pieces they were, but that's really kind of irrelevant. But the Tang, which is also an awesome orange drink that I remember from when I was a kid in the 80s. Tang is the server, and Clevis is the client, right? So Tang runs on a machine, and you can even run Tang in a clustered mode, right? So you might wonder, what if my Tang server dies, right? Well, you can run it in a clustered mode so that the Tang system can be highly available, right? And Brian had a follow-up doc on how he did that, where he had several Tang servers so that that sort of thing wouldn't happen, right? It's probably also a thing you want to look into how to back up, right? Because if your Tang server dies, you won't be locked out of your disks, but you'll have to go back to putting in the passwords. So still, make sure you've got those passwords somewhere, and make sure that so if your Tang server were to die, you'd have to rebuild it, basically, which you should be able to do using the system role, as long as the passwords for your disks and whatnot haven't been changed or something.
And so we would recommend, 1, making sure that you have the passwords to go along with your devices stored somewhere so you don't forget them. 2, that you run maybe a secondary Tang server. So if your primary goes out of whack, it's able to hit your secondary and still automatically open your encrypted volumes upon reboot.
Right. So here we are. We finished the playbook. Now I have a tab open here on Tang. We're just gonna quick. It's called Tang D. Should be running. Oh, maybe it's not called Tang D. Oh, did I typo it? No, I didn't. I didn't typo it.
Oh, it's a socket, not a service.
It's a socket. That's why. Okay. So there, the socket's up and running. I should have put that in my notes. See, when you try to just think you know a thing, you prove yourself wrong every time. All right, so the socket's up and running. There isn't a whole lot more to demonstrate. However, I can switch shares, and we can reboot the machine again. Give me just a second here. Let's turn off that one.
Because as part of that system role, not only did we set up the server, but we also configured the client too, right? To use.
Yes, yes, that did both. So we can turn this back on. There you go. I almost did the thing where Eric turned it on and I turned it back off because I was trying to get ahead of Eric. Sorry about that, Mr. Producer Man. So you can see some output here where it was doing some of the work that Ansible pushed out to it. What we're going to do, we're just at the login here, right? Now, remember, last time we rebooted, it hung. This time we're going to reboot it, and it should not hang. Should not. We're going to see.
Moment of truth. Did you do all the things right, Nate? We're gonna
Well, I mean, for the sake of time, I didn't go verify all the things, so we're going out on some trust here.
Just remember,
We're
folks,
gonna,
you know, with 50 years of shared experience, you too can just be like, yeah, it looks about right.
YOLO. There you go. Look at that. Same machine. We didn't do any changes other than letting the system role set up Clevis on C server 0, and now it comes up and let me see if I can log in here quick. Long passwords and live streams don't really work all that well, but the moment of truth, there's my vol in my super secret file. Didn't have to put in a password. Now, you might wonder what happens if you can't reach the Tang server, because we had a discussion internally, like this would be really cool if you take your laptop, which is Lux encrypted and set up to talk to Tang, right, using network-bound disk encryption, so that when you're at your desk at work and turn on the machine, it just comes up. But if you leave the premises, now it's locked, right? Guess what? It works. If it can't reach the Tang server, it'll simply ask you for the Lux password when you turn the machine back on. And we could demonstrate that if we wanted to by simply disconnecting the network or something. I don't know if it's that valuable at this point, but essentially what it does is if it can't reach it, it'll just ask you for the password the same way it did in my first demo.
Right on. So we're a little bit over time.
Right.
So thanks everyone for checking out encrypted disks today with us. Our next episode is going to be a wrap up of our security story arc. So we're just going to be tying some of the pieces together over the last, 5 or 6 episodes that we've done around security, compliance, and scanning with OpenSCAP and like all kinds of cool stuff. And then we're going to do some individual episodes, I think, for a little bit. Some, what we call those, episodic. We'll be episodic for a moment or two.
Sure, episodic. That's a good word.
Don't forget to tell your friends if you think they would find usefulness in Into the Terminal. Thanks for joining us. Nate, any words of wisdom about cryptography before we go?
Encrypt all the things.
That's right.
Thanks for watching, everybody.
Bye, everyone.